Hi everyone, this is Dr. Nak. Today we're going to learn about solving systems of linear equations in two variables. Here are our goals. Solve the systems of equation by number 1, graphing, number 2, by substitution method, and number 3, by the addition method. Now, when you hear the word linear, what do you think of? Typically, I assume that you will think it's a straight line. And you know what? That's exactly it. Now, we have learned how to write the equation of a line in slope-intercept form. Do you all remember we did y equals mx plus b? Right? So now, what makes it linear is this. If the exponent on the variable, by the way, m is a slope, so this is a constant, and then b was the y-intercept, so this is also a constant. So which means that the variables that we're talking about is just the x and a y. Now, if the exponent on both of the variables are 1, then we got yourself a linear equation. So for an example, if I have something like 5x plus 4y equals to 10, I claim that yes, this is a linear equation because exponent on each of the variables on x and y are 1. Now, here are some examples of that is not linear. So let me just write down this is linear. Now, what is not linear will be something like this. If you have a 5x squared plus 4y equals to 10. Now, this is not linear because the exponent on one of the variables is no longer 1. So this is not linear. Now, let's go with the words here, systems of equations, right? So what the heck is a system? System just means that you're given more than 2 linear equations. And altogether, that's called a system. For an example, 5x plus 4y equals to 10, that's a linear equation. And then negative x plus y equals to 5, that's also a linear equation. So together, this is called a system. So in this section, you're going to be given a system, and then our job is to solve for x and a y. All right, and then we have 3 methods to solve for x and a y. First method, we're going to do that by graphing. Second, by the substitution method. And the third, by the addition method. Given a system, there are 3 types of systems and 3 types of solutions. So let's go over that first. So here are your 3 choices. First one, the 2 lines actually intersect. And then the second case is 2 lines are parallel. And the third case is that 2 lines are pretty much the same. I mean, exactly the same, I should say. They're going to overlap each other. Now, each system has a name. So if it intersected at some point, that's called the independent system. Now, if the 2 lines are parallel, we call that the inconsistent system. And then if it overlaps, now that's called a dependent system. Now let's go over the 3 kinds of solutions that we're gonna get. Now please note that solution is where the 2 graphs meet. So for the first case, our solution is just at 1 point. So this looks like, what is that, 2, 3? All right, and the second kind is this. Look at the second system here. Do they ever intersect? No, so that means there are no solutions here. So inconsistent system does not have any solution. So I'm just going to write it as no solution. Now let's look at the dependent system here. Now remember, again, solution is where the 2 graphs meet. So how many solutions do you think we have here? You guessed it, infinitely many. So here, I'm just going to, where can I squeeze this? Okay, so we got ourselves 3 choices for the solutions. 1, you actually going to get a point of intersection. Second, no solutions. And third, infinitely many solutions. Let's take a look at example 1. Determine whether 8, 5 is a solution to the system 5x minus 4y equals 20 and 2x plus 1 equals 3y. Now, if 8 comma 5 is a solution to the system, then 8 comma 5 must satisfy both equations. So in order to do this problem, what we need to do is we check to make sure that if I plugged it in 8 in place of x, 5 in place of y, then the equation becomes a true statement. So let's first check the first equation. So the question is 5 times 8 minus 4 times 5, is that going to give us 20 back? Now let me work on the left hand side. So we have 40 minus 20, which gives us 20 equals to 20. So 8 comma 5 satisfies the first equation, but in order to be a solution, it has to satisfy both equations. So what we need to do is we're going to have to check for the second equation here. So second equation is 2x, so you're going to have 2 times 8 plus 1. Is that going to give us 3 times y, so 3 times 5? All right, so let's first work on the left-hand side. So the left-hand side is going to be, what is that? 16 plus 1, so this is going to be 17. And 3 times 5, that's 15, isn't it? So this does not equal each other. So guess what? 8 comma 5 is not going to be the solution to the system. Even though it satisfies the first equation, but it failed the second equation, right? So altogether, it's no longer a solution. Let's take a look at this graphically. So the first red line is the equation 5x minus 4y equals to 20, and the blue one is 2x plus 1 equals to 3y. Now, again, solution is where the two lines meet. So let me just jot down where that is. So it looks like this is going to be the solution here. Now, we're going to be able to find the points of intersection algebraically by using the addition method or the substitution method. But anyways, the actual point of intersection, according to my calculation, this is 64 over 23 and then negative 35 over 23. So that's definitely not 8 comma 5. So the 8 comma 5 is going to be at this point right here. Yes, it's going to lie on the 5x minus 4y equals to 20, but that point is not on the graph of 2x plus y equals to 3y. But anyways, let me just call this 8 comma 5 is not the point of intersection. Therefore, not a solution. All right, so now let's learn how to solve the actual system by graphing. Example 2, solve the system by graphing. The first equation is 2x minus 5y equals to negative 25, and negative 4x plus 5y equals to 35 is the second equation. Now, both equations are given in the standard form. So I don't know if you remember what the standard form looks like. So let me just write that out. Standard form. It's going to look like something like ax plus by equals to c. All right. And then the slope-intercept form is your favorite, probably. Y equals to mx plus b. And then there's another one. It's called the point slope form. Which is y minus y sub 0 equals m times x minus x sub 0. But anyways, if you're given the standard form, the quickest way to graph it is by finding the x and the y intercept. So let me just write that. So the fastest way is find the x and y intercept. Now, if you're given the slope intercept form, the quickest way to graph it is by using the y-intercept and use the slope to perform rise over run. Now, point slope form, Well, just multiply everything out and then either make it into a standard form or the point slope form. But anyways, let's take a look at this one. So both equations are in standard form. So in order for us to graph this, I would find the x and the y intercept for both equations. So let's first take 2x minus 5y equals to negative 25. And then we're going to find the x-intercept and then the y-intercept for this. So how do you find the x-intercept? You set y equals to 0 and you solve for x. So let's do it. So you're going to have 2x and then minus 5 times 0 equals to negative 25. So this is 2x equals to negative 25. So the x is negative 25 over 2. Please keep your answer in exact form. Exact form means fraction. Do not convert this into a decimal. All right, so that is that's the x-intercept for the first equation. Now, how do you find the y-intercept? Well, you just do the other way around, right? So the y-intercept is, you set x equals to 0 and solve for y. So let's do that. So x equals to 0. So you're going to have 2 times 0 minus 5y equals to negative 25. So here you're going to have negative 5y equals to negative 25. So dividing by negative 5 on both sides, and you're going to have y equals to 5. Now let's do the same thing for the second equation, which is negative 4x plus 5y equals to 35. So let's go with the x-intercept. Again, you're going to have to set y equals to 0 and solve for x. So you're going to have negative 4x plus 5 times 0 equals to 35. So this is going to be negative 4x equals to 35. Dividing by negative 4 on both sides, and you're going to have x equals negative 35 over 4. Now, when you graph it out, yes, of course, you can use your calculator to put this in a decimal form. But please always leave your answers in exact form. All right, but anyway, so let me just box that. That's the x-intercept for the second equation. Now, let's go with the y-intercept. So you're going to have to set x equals to 0. And then just solve for y. So this is going to be 5y equals to 35. So the y is 7. All right, so let me keep those in mind and let's graph it out now. All right, so I just pretty much copy and pasted what we just computed. So now what we're going to do is let's first graph up the first equation, which is 2x minus 5y equals negative 25. So the x-intercept is negative 25 over 2, which is negative 12, 5. I knew we were going to run out of room. Okay, so this is negative 11, negative 12. So x-intercept is negative 12.5. That will be this point here. And then the y-intercept is 5. So it will be, so this goes by 2, 4, 6, 8, 10, right? So the 5 is going to be here. All right, so now let's draw the straight line through it. And then let's work on the next equation. So in this case, x-intercept is negative 8.75. So that's negative 2, negative 4, negative 6, negative 8. So this is like midpoint is negative 9. So this is going to be like maybe at this point here. Yikes. This is going to be very difficult to find the points of intersection, I think. So the y-intercept is at 7. So 5, 6, 7, that will be here. All right, now let's draw the line. It's kind of difficult to find actual points of intersection just because our graphing paper is not too precise. But let me just jot down what our guess is going to be. So my guess is the point of intersection. What is this point? When x is negative 5 and then y is 3. Now, that's my guess. But in order for me to double check my answer, I should plug that possible solution into our system to make sure that negative 5 comma 3 is going to satisfy both equations. So that's what we're going to do next. Okay, so we're going to check. So let me just write down the ordered pair, negative 5 comma 3. Please let it work. So let's go with is 2 times negative 5 minus 5 times 3. Is that going to give us negative 25? So the left hand side is going to be negative 10 minus 15. Yes. So this is negative 25. So it matches up. Now let's take the second equation. Okay, so you're going to have negative 4 times negative 5 and then plus 5 times 3. Is that going to give us 35? So here you're going to have 20. Oh, yay, plus 15. Booyah. 35. Yes, yay. So we graphed it right. So therefore, let's write down the, let's not forget to write down our final answer. The solution set is that this curly bracket reads as the solution set is negative 5 and then comma 3. So this is going to be our final answer. Alright, so let's now learn how to solve the system by this method called the substitution method. The best way to do it by the examples, but there are a few steps. So here are the steps. So step number 1, remember system, you're given 2 linear equations, right? So take either one of the equation and solve for either x or y. It doesn't matter which one you're going to take, which one you're going to solve for. Now, number 2, substitute the value that you just got from step 1 into the equation that you have not touched yet. All right, and number 3, substitute the value that you're going to get from step 2 into either of the original equations to find the value of the other variable. You're like, excuse me, what the heck is going on? And then, okay, just go with it for now. We're going to do some examples in a minute. And number 4, check the proposed solution. All right, so let's do this. Examples 3, solve the system by substitution, which is the same system as what we just went over in example 2, which is 2x minus 5y equals negative 25 and negative 4x plus 5y equals to 35. All right, so let's go use the substitution method. So step number 1, pick either one of the equation, right? And then either solve for x or y. So it doesn't really matter if you take the first equation or second equation, but how about this? Just so that we all do it the same way, let's take the first equation and then let's just solve for x. Okay, so here I'm going to take the 2x minus 5y equals the negative 25, and here I'm going to try to solve for x. All right, so here what do we need to do? I need to add 5y to both sides. Then here you're going to have 2x equals negative, let me just write it as 5y and then minus the 25. Okay, so now what we need to do is we're going to divide everything by 2. So then we're going to have x equals 5y minus 25 all over 2. Okay, so let me box that because this is a very important information. So that's your step number 1. It says again, solve one equation for either x or y. All right, now we're going to go into step 2 now. We're going to substitute this value into the other equation that we did not touch. So which equation have we not touched yet? That would be the second equation, right? So we're going to take this nasty looking x values into in place of x for the second equation. So let's do that. So let me just write down step 2. So then what I'm going to do is negative 4, and then our x is 5y minus 25 all over 2, and then plus 5y equals to 35. All right, so now let's just simplify this a little bit. So 2 goes into 2 once and then into 4 twice. So here we have negative 2 times 5y minus the 25 plus 5y equals 35. I'm trying to do this step by step. Now I'm going to distribute the negative 2 to each term because I'm trying to solve for y now. All right, so then if I do that, we're going to have negative 10y plus 50 plus 5y equals 35. Okay, so now let's combine negative 10y and then plus 5y. I'm running out of room, so I am going to go over here. Okay, so then what do we get? Negative 5y and plus 50 equals to 35. So you're going to have, let's subtract 50 from both sides. Then here we're going to have negative 5y equals negative 15. Now dividing by negative 5, then our y value is going to be positive 3. So isn't this exactly the value that we got for our y coordinate by graphing it? Okay, but it better be the same or we did something wrong. Now, that was step 2. So now let's talk about step 3. Now, step 3, it says substitute the value from part 2, which will be second step, not part 2, second step, into either of the original equation. So now what we're going to do is we got the y value. Now we need the corresponding x value. So how we're going to get that is this. Take either one of the equation, right? And then replace y equals to 3. Then you should be able to solve for x. So pick the nicer looking one, like which one looks cuter to you. I think the top one looks cuter, but you can pick the second equation if you like. So here, right, what I'm going to do is I'm going to take the first equation. So I'm going to have 2x minus 5y, which is going to be 5 times 3 equals to negative 25. Then we're going to have 2x minus 15 equals to negative 25. So add 15 to both sides. And then we're going to have 2x equals negative 10 dividing by 2. Then we're going to have x equals negative 5. Let me just box that. So this is exactly what we got by solving the system by graphing. But anyway, since I'm running out of room, let me just go to the very top. So therefore, our solution set is going to be negative 5, comma 3, as we expected. So let me just box that for our final answer. Our next method that we're going to be learning is solving the system by this thing called the addition method. Again, the best way to do it by examples, but here are the steps. It may not make sense to you if you've never seen this before, but let's just read it through. So step 1, write both equations in standard form, which is ax plus by equals to c. Now, number 2, if needed, multiply either equation or both equations by appropriate non-zero numbers so that the sum of the x coefficient or the y coefficient is 0. Oh boy. Okay, now step 3, add the equations in step 2, and then step 4, solve the equation in one variable. Step 5, back substitute the value obtained in step 4 into either of the given equations. And lastly, check your solution. You're like, excuse me, that was way worse explanation than the substitution method. So you know what? Let's do this by examples. Example 4, solve the system by addition. Now I'm taking again the same system as in example 2 and example 3 that we just did. Okay, so step number 1 is this. Step number 1 has been done already because they're both in standard form. Now, when you put this in standard form, make sure that x's line up and then y lines up. Y's lines up, not the wine. What am I thinking? And then the constants line up after the equal sign. Okay, now step 2 is this. Our goal is to add this together, right, vertically, so that I can either get rid of x or the y. So meaning you want to make the coefficient on either x or y equals to 0. But this is good to go because look, if I add this vertically, right, do you see that y term is going to cancel out? So coefficient on the y becomes 0. Does that make sense? So here it's already been set. So step number 1 is done. Step number 2, I'm going to add this together. So meaning 2x minus 5y equals to negative 25. Negative 4x plus 5y equals to 35. So now by adding this together, notice that this is going to cancel out. That's exactly what we want. We want to kill either x or the y. Okay, so now let's write down the remaining. You're going to have negative 2x equals to 10. All right, now how do you solve for x? Just divide it by negative 2. So here our x is going to be negative 5. Boom, done. I mean, not completely done, but at least we got our x coordinate for the solution. Now let's solve for y. So step number 3, oh, I think we just did step number 3, sorry. Step number 4 is solve the equation one variable. Okay, never mind, we just did that too. Now step 5, we're going to back substitute this value into either of the given equations. So again, you can take the first equation or second equation. And what we're going to do is, since we already have an x value, we're going to find the corresponding y value. So again, let me take the first equation. It doesn't matter which one you take. So here, if I take the first equation, which is 2x minus 5y equals to negative 25. Now let me replace our x equals to negative 5 into here. So then here you're going to have 2 times negative 5 minus 5y equals to negative 25. So then negative 10 minus 5y equals to negative 25. So adding 10 to both sides. Then you're going to have negative 5y equals to negative 15. Is that right? Yep. And then dividing by negative 5. And then here y equals to 3. So do we get the same answer? I hope so. So therefore, our solution set is negative 5, 3, as we expected. So let me box that for the final answer. Now, for this particular system, which method was the easiest to you? Well, to me, just for this example here, I would choose the solving the system by addition method. To me, that was the easiest. And the second easiest one was, to me, was the substitution. And then the last one was, for me personally, is graphing, just because you know my graphing skills by now. But anyways, depending on what kind of problems that you're given, you have to pick and choose which method that you're going to be using, unless you're told to use a specific method. Let's practice a little bit more on solving the system by the addition method. So here's example 5. Solve the system by addition. 3x plus 2y equals 48. And the second equation is negative 8y equals negative 9x minus 24. So step number 1, we need to make this both into a standard form. So what we need to do first, guys, good to go. Now the second equation, we need to flip it around. So if I flip this around, I need to add both sides by 9x, correct? So then let me just rewrite the system then. So our new system is 3x plus 2y equals 48. And then here, if I add 9x to both sides, then here we're going to get 9x minus 8y equals negative 24. So now we're both in standard form, so we're good to go. All right, so now what we need to do is we need to become smart and pick and choose which variable that we want to get rid of. Okay, so if I were you, or I mean, you can do either way. I mean, you can try to get rid of the x or the y, but notice that in front of y, I already have a positive and negative, right? So that means what? If I have positive 8 here, and then if I leave just the bottom alone, and if I add those two together, do you see that the y variable is going to disappear, right? Because the coefficient on y becomes 0. So we need to force that to happen. So what number do I need to multiply to 2 for us to get positive 8? That will be positive 4, isn't it? 4 times 2 is 8. So what we're going to do is this. We're going to take our first equation, multiply the whole entire thing by 4. All right. So now let me try to write down the new system. So our new system is going to be, I'm going to distribute this 4 to each term now. All right, so then here you're going to get 12x plus 8y equals 192. And then just copy and paste the other second equation. So you got 9x minus 8y equals to negative 24. Now we're good to go, because look, if I add this vertically, then we can kill the y, right? So let's do that. So I'm going to add this vertically now. Here we're going to have 21x and bye-bye y variable. And then this whole thing's going to equal to 192 minus 24, 168. All right, now what we're going to do is we're going to divide that by 21. So divide that by 21, and then our x is going to be 8. All right, looking good. Now, next step is this. You have to take either one of the equation and then solve for y. So here, it doesn't matter which one you want to take. So which one do you want to take? First equation, second equation? You know what? Let me take the second equation this time. All right, so I'm going to take the second equation, which is negative 8y equals negative 9x minus 24. And then I'm going to plug this 8 in place of x. All right, so then here you're going to have negative 8y equals negative 9 times 8 and then minus 24. So we're going to get negative 8y equals negative 72 minus 24. So negative 8y equals to negative, what the heck is that, 96. Now if I divide that number by 8, actually negative 8, sorry about that, negative 8. Then what are we going to get? Our y is going to be 12. All right, looking good. So it looks like our solution set is going to be 8, 12. Oops, on the previous example, I forgot to check our solution, but that's okay because we already know what the answer is going to be. All right, so now let's check our solution here. Okay, so let me just go over here. So check. So what is our proposed solution? 8, 12. Oh, I forgot to box that. All right, so let's take the first equation, which is 3x plus 2y equals to 48. So you're going to have is 3 times 8 plus 2 times 12. Is that going to give us 48? All right, let's do it. So here, let's just compute the left-hand side. 8 times 3, 24. 12 times 12, 24, which equals to 48. Yes, it checks. It checks. Now let's go with the second equation. So the question is negative 8y, which is negative 8 times 12, is that gonna equal to negative 9x, x is 8, and then minus 24. All right, so let's compute the left-hand side. Negative 8 times 12 is negative 96. Now let's compute the right-hand side. So here you're going to have negative 72 minus the 24, which is negative 96. So it matches up. So we computed it correctly. So therefore, our official answer is going to be 8, 12. Let's do another example. Example 6, solve the system by method of your choice. So here we have 7x minus 3y equals to 4, negative 14x plus 6y equals negative 7. So you can pick and choose whatever you like. You can solve this by graphing or substitution method or addition method. But to me, since this is already in standard form, I like to use the addition method for this. Now, it doesn't really matter which one you want to get rid of here. They're equally pretty easy to find a nice constant to multiply so that I can kill the x or the y. So how about this? Let's kill the y. So what I need is, I need this to be negative 6y. So negative 3 times what is going to give me negative 6y? That's going to be 2. Right, so what I'm going to do is I'm going to multiply the top equation by 2, and I'm going to use the addition method. All right, so let me just rewrite. So next I'm going to distribute. Don't forget to distribute the 2 to the right-hand side either. That's a common mistake that a lot of students make. But anyways, let me rewrite. So this is 14x minus 6y equals 8. And then let me copy and paste the second equation. Negative 14x plus 6y equals to negative 7. All right, now we're gonna add vertically. Oh no, do you see something funky is gonna happen here? Notice that we have a 14x minus 14, that's gonna go to 0, and then this is gonna go to 0 too. So here we have 0 equals 8 minus 7 is 1. Oh no, what the heck, right? So 0 equals to 1, so this is not true. 0 does not equal to 1. So when you run into cases like this, it means that no matter what kind of x and a y value that you're going to plug it in, it is not going to satisfy both equations. So when you get a false statement like this, your answer is automatically no solutions, which indicates that two lines must be parallel. So let me just first write this out. So this is not true, which implies that your answer is no solutions. And the notation for that is usually curly bracket with nothing in it, or circle with a slash. But I will try to avoid circle with the slash because some of you write 0 just like that. So I would just go with the curly bracket with nothing in it, or spell out just no solutions, fine. Okay, so let me just box that. So here's the actual graph of 7x minus 3y equals to 4 and negative 14x plus 6y equals to negative 7. So graphically, it verifies that there are no solution to this system. Example 7, solve the system by method of your choice. As you can see, I kind of got too lazy to write the instructions now. All right, but anyways, solve 4x equals 36 plus 8y and 3x minus 6y equals to 27. So again, you can pick and choose whichever method that you want. But you know what? As right now, I was going to do this by the addition method, but I just realized that maybe substitution method will work nicer. Because look at the top equation, right? If I divide it by 4 on both sides, I should easily solve for x, and then I don't have to deal with fractions even if I divide it by 4. So you know what? I'm going to do this by the substitution method. Okay, so first what I'm going to do is I'm going to take the first equation, which is 4x equals 36 plus 8y, and I'm going to divide this by 4. So then what do we get? We're going to have x equals 9 plus 2y. All right, so it's looking nice already. So now next step is this. You're going to take the equation that you have not touched, which will be in this case the second equation, and replace the x in the second equation with 9 plus 2y. Okay, so let me just write every step out. So I'm going to take the second equation, and then I'm going to replace this x here. All right, so let's do that. So then you're gonna have 3, and then x is 9 plus 2. I make sure to put a parentheses around this, and then minus 6y equals 27. Now let me distribute the 3 over. Then you're gonna have 27 plus 6y minus 6y equals to 27. All right, so then this is going to cancel. Now what's going to happen? 27 equals to 27. What? Yes, of course 27 equals to 27. And again, just like in the previous example, we got our funky situations going on here. All the variables disappears and you're just left with two numerical values. Now, unlike the previous example, we had a 0 equals to 1, which is not a true statement. But here, 27 does equal to 27, which is a true statement. Now, when you get that, your answer is automatically going to be infinitely many solutions. Now, by getting the true statement, right, in this case, let me just write this as true statement. With that, it's telling you that basically any ordered pair that satisfies the first equation will also satisfy the second equation, no matter what. All right, so now how do you write that answer, right? So here, let me just write it as if you get a true statement, which indicates that there are infinitely many solutions. Now in mathematical notation, you're gonna write it like this. Set of all ordered pairs, x comma y, such that. Now, next step, you can put either one of the equation. So we're going to have 4x equals 36 plus 8y, or you can have this equation part as 3x minus 6y equals to 27. So this notation indicates that there are infinitely many solutions. All right, let's do another example. Do not panic. Example 8, solve by the method of your choice. So we have 3 over 2x plus 1/4 y equals negative 1 over 8. And 1/2 x plus 1/3 y equals 1/3. I know, when you look at fractions, especially it's more than one in one equation, you freak out, you know? I used to do that all the time, but it's not as bad as you think. So let me just teach you the little nice trick. All right, so if you don't want to deal with fractions, then this is one trick. Multiply the equation by the least common denominator. So we have 2, 4, and an 8. So what's the LCD, least common denominator? That will be 8. So let me write that out. LCD equals to 8. Now, what about for the second equation? Second equation, look at the denominator. We have 2, 3, and another 3. So the least common denominator will be 6. Here's the trick. Multiply the first equation by the LCD, which is just 8. So what I mean is multiply this whole thing by 8. Now remember, 8 is same thing as 8 over 1. And then for the second equation, multiply by its LCD, which is going to be 6. So here, 6 is same thing as 6 over 1. So you're like, what are you going to do? So here's what I'm going to do. I'm going to distribute this 8 to each term, and then you'll see that the fraction is going to disappear. And we're going to do the same thing for the second equation. We're going to distribute the 6 to each term, and then voila, fraction will disappear. All right, so let's do it. So first, let me just do this step by step so you can follow what I'm doing. So if I distribute the 8 to the first term, then let me just keep with the same color here. So we're going to have 8 over 1 times 3 over 2x, and then plus another 8 over 1 times 1/4 y. And don't forget to multiply by the 8 on the right hand side of the equation. A lot of students forget that. So here you're going to have 8 over 1 multiplying here by negative 1 over 8. All right, so now let's do the same thing for the second equation. Okay, so the second equation, I'm going to distribute the 6. So we're going to have 6 over 1 times 1/2 x, and then plus 6 over 1 times 1/3 y equals 6 over 1 multiplying here by 1/3. So far so good. All right, now let's take one equation at a time. So let's first look at this term here. Do you see that 2 is going to go into 2 is going to go into 2 once, and then also into 8 4 times. So here I can reduce this a little bit. So here 2 goes into 2 once, and then in 8 4 times. So who's left over? We have 4 over 1 times 3 over 1 times x. So that's just 12x. Now we're going to do the same thing for 8 over 1 times 1/4 y. Notice that I can cancel the top and bottom by divided by 4 to cancel this 4. 4 goes into 4 once and into 8 twice. So what do we have left over? Just a 2y. Now that's going to equal to, now if I multiply the 8 over 1 times negative 1 over 8, we're just going to have negative 1 left. All right, looks much cleaner than the original equation. Now we're going to do the same thing for the second equation now. Notice that 2 is going to go into 2 once and then into 6 3 times. So what's left over? Just the 3x. And then 3 goes into 3 once, into 6 twice. So what's left over? We're going to have plus 2y, and that's going to equal to, all right, 3 goes into 3 once and then into 6 twice. So that's going to equal to 2. Look at it. Aren't they much nice looking now? All right, so let's go from here. So you need to decide which variable that you want to get rid of. So I think it's a lot easier for us to get rid of the y, because all I have to do is multiply one of the equation by negative 1. So let me just do that. So let me see. changing up the color a little bit. So I'm going to multiply by -1. Now let's rewrite the system. So here you're going to have 12x plus 2y equals -1. And now you're going to have -3x minus 2y equals to -2. Now, do you see that if I add them together? So here I'm using the addition method. Now, 2y is going to disappear, and what do we have left? We're going to have 9x equals to -3. Dividing by 9 on both sides, then what are we going to get? We're going to get x equals to -1/3. All right, so let me just box that. Now, we still need to get the corresponding y value. So if I were you, I will, I know that you don't like fractions, but I would be feel much safer if I plug this into the original equation. One of the original equations, I should say. All right, here's the reason why. Of course, because this system is equivalent to this system that we got. I know this looks way nicer than the original system. However, suppose you made a little mistake. So maybe if I said, 2 goes into 2 once into 6 twice by accident, then do you see that this whole system is going to be wrong? Which means that if I plugged it in, x equals to -1/3 into the wrong system, then we're going to get a wrong answer. So just to be on the safe side, let me go back to our original equation. It doesn't matter which one you're going to pick. So you know what? Which one looks cuter? Let me take the second equation. All right, so here I'm going to use 1/2 x plus 1/3 y equals 1/3. So here you're going to have 1/2 times x, which is -1/3, plus the 1/3 y equals to 1/3. All right, so then this implies that you're going to have -1/6 plus 1/3 y equals to 1/3. Yes, now from here you can add by 1/6 to both sides if you like. Or if you don't want to deal with fractions, again, you can multiply everything through by the LCD of 6 and a 3, which is 6. So I don't know which way you want to do this, but let me just add plus 1/6 to both sides in this case. Adding these two fractions are not too much of a hassle. All right, so then let me just bring it up here. So then what do we get? We're going to get 1/3 y equals 1/3 plus the 1/6. So here, if I'm going to get a common denominator, I need to multiply 1/3 by 2/2. So then we're going to get 1/3 y equals to 2/6 plus the 1/6, which is going to give us 3/6, which is just 1/2. All right, so therefore, what do we got? Right now, we have 1/3 y equals to 1/2. Now, how do I solve for y? Well, multiply by the reciprocal of 1/3 to both sides, which is just 3. So I'm going to multiply here by 3, multiply the right-hand side by 3. Then what we're going to get is y equals 3/2. All right, so let me just box our proposed solution. And here is my proposed solution. I'm running out of room as always, so let me just write it up here. So therefore, I claim that my solution set is -1/3, 3/2. Now, before I officially box this, what we need to do is we need to check our solution. So let's do that. All right, so what I just did was I just copy and pasted our original system and our proposed solution. Okay, so now let's check. All right, so let's check to see if -1/3, 3/2 is going to satisfy the first equation. So here we go. It's 3/2 times -1/3 plus 1/4 times 3/2. Is that going to give us -1/8? All right, so let's compute the left-hand side. So if I compute the left-hand side, I can cancel these 3's out. So you're going to have -1/2. And then here you're going to have plus 3/8. All right, so now let's make this into a one fraction. Denominator is going to be 8. So that means that I need to multiply this fraction by 4/4. So then here you're going to have -4/8 plus 3/8. which is going to give us negative 1 over 8. Does it match up on the right hand side? Yes, it does. Check. All right, so it satisfied the first equation. Now let's check to make sure that it's going to satisfy our second equation. All right, so then let me just start out with 1/2 times x, which is negative 1/3, plus 1/3 times y, which is 3 over 2. Now, is that going to give us 1/3? All right, so again, we're going to work from the left-hand side here. So here you're going to get negative 1 over 6. And then here I can cancel out the 3. And then here you're going to have plus 1/2. All right, so now if I'm going to add this together, I need to multiply this fraction by 3 over 3. All right, so then here you're going to have negative 1 over 6 and then plus 3 over 6. And then here you're going to have 2 over 6, which is 1/3. Does it match up? Yes, it does. All right, so officially, therefore, our solution set is negative 1/3, comma, 3/2. Was it that bad? I don't think it was too bad, but make sure to know the trick by multiplying everything through by the LCD if you don't want to deal with fractions. All right, now I'm going to stop here. Good job, everyone, and if you have any questions at all, please let me know.